que eu acho que precisa voltar a exercer assim, com mais força na universidade, no Estado, né? Porque hoje o momento é muito fértil para o que vem aí para frente. Obrigado.
E aí eu queria convidar todos para o lanche agora, e em seguida nós temos a palestra de encerramento do professor Ron Shen.
Bem, nós vamos começar então essa última sessão. E eu vou fazer a apresentação do palestrante em português, já falei para ele. Ele é professor em Berkeley há vários anos, fez a graduação ainda na China e o doutorado em Harvard, nos Estados Unidos, tendo sido um dos primeiros alunos do Nicholas Bloomberg, que foi o pai da ótica não linear, que é pai, está vivo ainda, né? E o Ron tem trabalhos fundamentais de ótica não linear, inclusive trabalhos dos primeiros anos da ótica não linear, né? Trabalhos de 1964 que se tornaram, então, fundamentos de tudo que se fez por todos esses anos de lá para cá. Além disso, todo estudante de ótica não linear já ouviu, já conheceu, já consultou o livro que ele escreveu de ótica não linear, que, apesar de ter sido escrito em 1984, é quase que uma bíblia para todos nós que olhamos para isso, pelo fato de ter sido muito fundamental, não é um livro de atualidades, mas é um livro de fundamentos da ótica não linear, que foi muito bem escrito e que é utilizado até hoje. Então, por todas essas razões, pelos vários trabalhos que ele fez, muito ativo, trabalhando em várias áreas, um espectro muito largo de áreas, então, ele é reconhecidamente um dos nomes mais importantes dessa área de ótica não linear. Bom, então, por isso, então, nós convidamos, e é claro que é um prazer muito grande ter ele aqui conosco, tendo vivido um pouquinho da história do departamento. Quem escreveu isso aqui não fui eu, foi ele que escreveu. E ele me perguntou se está escrito corretamente. Eu disse que sim, né? Falta o acento lá da física, mas eu perguntei, mas foi o Rios que lhe ensinou a fazer isso? Ele disse, não, eu aprendi agora durante as palestras, né? Então, o texto é dele, foi ele que falou. So, Ron, it's a great pleasure to have you here.
Thank you very much. Well,
and I told them that you know a lot of Portuguese now, okay? So if they want to raise questions, they can speak in Portuguese.
Yes.
Everything is okay. So,
okay.
You have one.
Yeah. Thank you very much, Sid. Whatever you said. Thank you. It's a great pleasure for me to visit here and to participate in this anniversary. And it's, of course, always a pleasure for me to visit Recife and the university. I should thank Sid and Seo and all the others for inviting me. Now, I was very impressed by all the talks that I have been listening. And you think that I probably be very familiar with Portuguese already. And what I can get sitting there is to compose these words together. And I hope the grammar is correct. Well, I should say that I was really impressed by all the speakers because they seem to be able to speak so fluently, so fast, and yet can still excite the resonances. So you probably would not expect a talk like that from me. And in fact, I need to apologize first because I don't really know what to talk about. I came in 2 days ago and asked Professor Sid what I should talk about. And he said, I can talk about anything I want. And that's a difficult job because I don't know what anything would be interesting to you. So I think I'm just going to ramble. Oh, thanks. And just talk randomly on different things. And the first thing I have in mind is, of course, to think back about the visits before. And the first visit I had was in 1975. And as was already mentioned, there was this scare of flood, and the dam was going to break. And Professor Engelberg showed us that that's not true. But in any case, I didn't get scared because I didn't know Portuguese that well. So, yeah. So anyway, the first visit was very, very pleasant. We had a great host. And at that time, I think Professor Sergio Rezende just came back from the US visiting Chacarino's group at Santa Barbara. So the first visit was, of course, very exciting. And what I remember was the beach was empty. There was no high-rises at all. And all you could see on the beach were children playing soccer. And there were banana trees sort of everywhere. And you can pick the banana trees from the street, from the tree anytime. So that was, looks like, paradise. But if I talk about the university, the department, I remember the department was in the old building. Mm-hmm. And you probably had a lab. I mean, you just came from Harvard back?
No. At that time, I was going to Harvard.
Oh, going to Harvard. Yeah. So then you didn't even have a laser at that time.
Yes, we had an argon laser at that time.
Yeah. So it was the second time, that's in the 80s. Mm-hmm. And then things have changed. The department moved to the new building, this one. Mm-hmm. And the labs are pretty nice. Only problem is very little equipment. Yeah. So you had a quanta-ray laser at that time.
Mm-hmm. And the one that's in the hall downstairs.
Uh-huh.
We have there.
Yeah, and I always remember you had a optical table like this, mm-hmm. with sparsely few pieces of optical mounts, mm-hmm. Right? So that was the second time. The good building, but the lab was not so well equipped. But this time, the building became old. The labs became so well equipped, right? I mean, it looks really exciting because you have so many new great projects going with sufficient equipment and all that. So I can see the progress is really true, although I don't know whether the university has improved as much as the city, because Recife is now like Rio. So your university should look like at least the top university of Sao Paulo. So anyway, I think you have been growing really well, and in another 5 to 10 years, hopefully you will have a new building with a lot of equipment in the lab. Yeah.
Okay.
Yeah.
You may use this.
Oh, okay. Adjust. Okay, change. All right.
To change that.
This one. Okay. Before I go talk about the God. Let's say, so I should say a little bit how I got connected with Receive. Of course, I knew essentially all your founding fathers in 1975. And Sergio, I think we met even before you came back, when you were with Jacarino, right? Yeah. And then I had CEOs come into our lab for a year, and we really enjoyed his coming to help us. He worked on the first surface-enhanced surface field enhanced luminescence on metal particles, nanoparticles. And I think nowadays people started to pick up, and your paper has been very much cited. And then I later in the around 90s, I had a student from Paulo Miranda, and he worked on liquid surfaces using nonlinear optical spectroscopy and did tremendous work. And he is now a professor at University of Sao Paulo, one of the campuses.
San Carlos.
San Carlos, okay. Yeah, so these were my, Miranda's father is a nuclear physicist here, right?
No, not nuclear.
Not nuclear.
No, no. A theoretical solid state.
Oh, theoretical solid state physicist. Okay, so that's my connection also. And then with Professor Sid, he visited Harvard, working for 2 years in Brombergen's group, lab, and that was the lab I came from. He left after the visit, coming back to Receive, and sort of pioneered nonlinear optics in Brazil. And I left Harvard, went to Berkeley, and tried to expand nonlinear optics in the West Coast, in Berkeley. Now, after that many years, he has built a optics group, or nonlinear optics group, that's the best in Brazil. This time I came in, visited all the optics lab, and right after the visit, I said, Sid, your optics group must be the best in Brazil. And he said, yes. So that's great. So how about Berkeley? Well, I worked there for quite some time, and now I retired, and no one in the physics department is working on nonlinear optics anymore. So you can see who is more successful. Well, we talk about connection to Brombergen. So who's Brombergen? Here's Brombergen, and that's probably when he got the Nobel Prize, and that's what he's now. And the contribution is, the biggest contribution was in that paper, and you can see the Maxwell wave equation. And the important thing is that the source term, the polarization, is in general a function of the electric field, which can be a nonlinear function. And obviously, the biggest contribution in this paper is to simplify that equation into power series. Okay? And although that seems to be trivial, but it has huge impact. Right? As you can see, you expand into power series, and then you find that from the solution of the Maxwell equations, he first defined the so-called nonlinear susceptibility instead of linear dielectric constant or linear susceptibility, and considered the local field correction, which is very important for highly nonlinear response. And they solved the couple wave equations. They showed the couple wave equation and solve it for wave mixing. They show that phase matching is very important. And quasi-phase matching becoming very, very popular in nonlinear optics these days. It was periodic layers of the nonlinear materials. You could get phase matching, although normally it would not be able to be phase matched. And they also proposed that you can have phase match generation in cavity. And in that paper, they also talk about terahertz generation by difference frequency generation. And this is now a huge field in optics, terahertz spectroscopy. And they propose upconversion for detection of very weak signals. And people later showed that's a great method to detect infrared because it can have sensitivity of counting photons in the infrared. So this is, of course, tremendous contribution to nonlinear optics. And then later on, after years of development, we can see nonlinear optics has impacted all areas of science and technology. And for that, Brombergen got the Nobel Prize in physics for his contribution to laser spectroscopy. At this point, I should say that Brombergen was invited to this occasion by Sid. And he said he regretted for not being able to come because his wife's health condition is not good. It's not because his health is not good. He is 92 right now. And when I saw him a few weeks ago, he went to Berkeley to give a talk. And he said that he couldn't come because his wife couldn't walk very well and so on, because if he comes, he will come with his wife. So he said sorry. And the amazing thing is he's 92 and he's playing tennis a few times every week. And then a few weeks ago when I saw him, he was very upset because he said he couldn't play tennis for the next 2 or 3 weeks because he just fell down from bicycle. So people said, why you fell down from bicycle? He said, I was riding the bicycle. So it's really amazing that he could still, just 1 week before he's traveling to Berkeley, he fell down from the bicycle and hurt the legs. So that's sort of my connections with Recife. And so what else should I talk about? Let's see. Well, maybe if we talk about the development over the years, and we can all see very clearly that Brazil is growing economically very fast. Universities are improving so quickly. And at Recife here, you can also see that things are going so rapidly up. And I visited the labs. I can see you have great projects going on. You have very innovative ideas. You have good students, good faculty. By the way, your faculty is almost as large as our faculty, 40 people, right? We have 43. And your condensed matter optics group is probably 2 times larger than ours. So I can see you have very exciting research going on. And so this always makes me feel a comparison with China. I have been visiting China quite frequently too, and see the rapid growth in China too. And so both countries are taking off, and it's a question of which one is faster, but steady, not only just fast, but growing steadily. And I think Brazil has certain advantages. I mean, you, of course, have very rich resources, and China is kind of poor in resources. But you don't have enough people. China has too many people. China has too many people. And so if you talk about university or physics department here, it's the same problem. You don't seem to have enough students. And in China, they probably have too many students. Then in comparison, I would say, you have strengths, they have strengths. Your strength is in the foundation. I think, as far as academic is concerned, your foundation is more solid. The average standard of the faculty is certainly better than the average standard of professors in China. And I'm not talking about comparing the top, just average. On the other hand, you don't have a critical mass in students. And so my feeling is you probably need to put more effort in recruiting students. I'm just talking randomly. So let me give you one example. There's probably the best university in Taiwan. That's the National Taiwan University. And to get into universities in Taiwan, you have to pass entrance exam. I mean, everyone takes the same exam. And then they will be distributed into different universities. And those students, of course, the top students will have their choice. The poorer students will have less choice. So therefore, the university can always rank which department on campus is the best, because you can tell from how many students want to go into which department. Okay? So over many years, it's always electrical engineering and computer science. That department has the best students and many students. And physics, for some reason, there was a period that the physics department was very popular. And that was early days when Shen and T.D. Lee got the Nobel Prize. That influences a lot of young people. But then later on, physics does not have the job market. So it decayed. So for many years, the physics rank was always sort of beyond 10, 15, or 20, okay? Compared with ECS, the electrical engineering, it's much lower. But then, about 10 years ago, someone pulled the political string and got the government to build a very nice building for physics department. And so the physics department moved into the new building. And next year, the physics rank became #1. So that shows, there's a certain factor that could affect the students' intention to come. And I think, again, in comparison with China, you will have, probably your budget is less than China. And so, again, this is probably the politics affecting how much the government would like to emphasize science. I know that Professor Rezende has been influential in Brazil, but probably you cannot fight all these other politicians. But in China, it's a communist country. You have the Communist Party controlling everything and so on. And it happened that the more recent leaders, when they were in the universities, their majors were in engineering or science. That makes a big difference. So the other is the exchange program. I think throughout Asia, the emphasis is becoming more and more on exchange with foreign scientists or engineers, in the sense that they would like to become a global institutions. So the word is global. So the universities are trying hard to hire foreigners onto the faculty. And I know that you probably would like to do the same thing. And compare with Chinese, Portuguese is much easier to learn. So I think you have that advantage at least. Well, I think I'm just going to stop here because there are a lot of possible comparisons. And if you have interest, we can always discuss later. How much time should I kill?
It's up to you.
Well, I don't want to occupy all your time unless you're interested. Well, I think I'm going to kill some time by talking about science a little bit, okay? And because this is a more general audience, I'm not going to go into very specifics. So I work in nonlinear optics. Probably Sid already introduced me. And so, of course, I'm going to talk about how nonlinear optics has been advanced and how the recent interest of nonlinear optics still going on. In any case, oh, I forgot to mention, so Bromberg and Charlotte got the Nobel Prize on laser spectroscopy. And you can see there are many, many different laser spectroscopy techniques. And the big titles are precision spectroscopy, coherent transient spectroscopy, multi-resonance, and wave mixing spectroscopy, ultrafast, and there are many small categories. In any case, with that many different spectroscopy techniques, you can see the impact on science and technology. So there are a lot of problems that could not be done without lasers. Now they all became possible. Okay. So what I'm going to, of course, this shows that the two of them really deserve the Nobel Prize. Okay. Now, what I'm going to emphasize here is the more recent advances. And of course, I have my choice, so it's not what people all agree on. But in any case, the important thing is nonlinear optics has impacted all areas of science and technology. And so the more recent advances is sort of like opening even more new fields, okay? More fields that have not even been touched before. Okay? So let me just talk first something simple but interesting. The question is, can nonlinear optical effects be observed at a single photon level with single atoms? And you would say, that's crazy. I can hardly see the single atom with linear optics. But if you do a quick calculation, assuming that the atom or the photon is in a little box of 1 micron cube, then you can say the energy density in that volume is about 1 erg per cubic centimeter. And you calculate the electric field, it's 1 kilowatt per centimeter. And that is the kind of field strength that will allow you to see nonlinear optics. Okay? So it is possible to see nonlinear optics with single photon and acting on single atom. So I just quickly show you one example by Kimball. And he put a